Okay, this video is going to deal with quiz 4, operations of complex numbers, and it's the solution. So we're going to go through the solutions of each problem. It might take a little bit of time, but make sure you understand how to do all the problems. Okay, problem 1, we have this 4, we're squaring 4i. So this is the way I'm going to square something, we multiply it by itself. And then I can multiply 4 times 4, that's 16, and then I squared. And I know that I squared is equal to negative 1. So it's 16 times negative 1, which is negative 16. So that's A for this one here. Now the numbers may not match up to your quiz because there's different versions, but they're all the same problems. This is one of the versions. This is I to the 38th. Now what I'm going to do over here, I to the first is equal to I to the second is equal to negative 1, I to the third is equal to negative I, and I to the fourth equals 1. And that pattern continues just to repeat itself over and over and over again. So any exponent that's a multiple of 4 will be equal to 1, I to that power. So I to the fourth is 1, I to the 8th would be 1, I to the 12th would be 1, and so on and so forth. And then, so what I do with I to the 38th, I to the 38th, I think to myself, what's a multiple of 4 that's just below 38, or close to 38? And that would be I to the 36th. And then what's left over is I to the second, because 36 plus 2 is 38. And I know that I to the 36, since that's the 36 is a multiple of 4, this I to the 36 becomes 1. And I to the second over here says it's negative 1. So this number right here is negative 1 plus. Now I to the 104th, 104 is a multiple of 4. So that becomes I to the 104 is just equal to 1. Because this is 104 is a multiple of 4, so negative 1 plus 1 is 0, and that's the answer to number 2. Number 3, I to the 61. We'll do the same thing. I to the first equals I to the second equals negative 1, I to the third equals negative I, and I to the fourth equals 1. And I'm looking at 61, and I'm asking myself, what's a multiple of 4 that's close to 61 but below it, and I'm looking at that's going to be I to the 61 is the same thing I to the 60th, which is a multiple of 4 times I to the first. So again, this number here goes to 1 because it's a multiple of 4. 60 is a multiple of 4, and I to the first is just I, so the answer would be I. Number 4, I to the 103rd. Well, 103 is not a multiple of 4. So 104 is, but that's above it. I want to go below that, so that's going to be I to the 100th times I to the third. And I got to figure, so this goes to 1, so this again, this is going to be 1. And then I to the third, if I look back, if I want to look back, wrong way. I to the third is negative I. So I'm going to say this is 1 times negative I. So the answer is negative I, and that's what that one would be. Okay. Number 5, now we're going to use the fact of the powers of I to simplify this. So I to the fourth is 1. So again, I'll write this really quickly. I to the first equals I to the second equals negative 1, I to the third equals negative I, and I to the fourth equals 1. Eventually we'll memorize that. You don't have to do this every time. So I to the fourth right here is positive 1. So that's going to be 8 times 1. Minus 3 times I to the third is negative I times negative I. And then I to the second, so plus 3 times I to the second is negative 1 times negative 1. And then 6i is just, I can write that as 6i, and then plus 4. And then I simplify this. This becomes 8. Negative times a negative is positive, plus 3i. And this is going to be minus 3 plus 6i and then plus 4. So now I look at this and I combine like terms. First I'm going to do the numbers without the i's. That's going to be this one, and this one. So 8 minus 3 is 5. 5 plus 4 is 9. So 9 is my number, the real part of my complex number, the number. And then the I part, these two will combine together to be plus 9i. So a complex number has a real part and an imaginary part. So 9 plus 9i is the answer to this one. Okay, now number 6 is the same principle. I'm going to have 5 times I to the 6th. I to the 6th is the same as I to the 4th times I to the 2nd. So this is 1. Okay, this part here goes to 1. So it's 1, so that's just 1 times negative 1. So that's going to be negative 1. So 5 times negative 1. And then I'm going to say plus 9. And then I to the 7th is going to be I to the 4th times I to the 3rd, which is 1 times negative I, or just negative I. So it's going to be 9 times negative I. So that's going to be negative 5, that's a minus 9i. Negative 5 minus 9i is this one right here, D. Okay, now I'm going to look at number 7. This one confused a lot of people because we have I written here and we have the square root of negative 4, which we have to turn into some type of something with I. So what I'm going to suggest is for this one is 7i doesn't change. We know that. Minus. Now I got to figure out what's the square root of negative 4. Now clearly there is no square root. That's why the I is involved. So that becomes equals I times the square root of 4. But the square root of 4 is just 2. So that's I times 2. Or we write that. So I write this I times 2 as 2i. So it's going to be 7i minus 2i. But 7 minus 2 is 5, so that becomes 5i, and that should be the answer right there. Okay, number 8. This one confused a lot of people because we see the parentheses and we think automatically we're going to start doing FOIL. But first of all, this says add. Second of all, there's a plus sign in between. So all we're doing is basically combining like terms. 2 plus 6i plus 3 plus 2i is really what this means. The parentheses are useless in this problem, other than they separate. This is technically one complex number, but the idea for simplifying would be to combine like terms. 2 plus 3, that's 5. 6i plus 2i is 8i, and that's the answer. 5 plus 8i, so that would be that one there. The next problem. Okay, this is where it gets a little tricky. Product means multiply, so I'm going to multiply 2 over 1 plus I times 3 minus I over 1 minus I. Now, I remember back in 5th grade when we learned to do fractions, multiply fractions, we multiplied the tops together, and then we multiplied the bottoms together. So the numerator is going to be the top. Now, remember, this is basically thought of as parentheses here, because that's all one number. So I multiply 2 times 3 minus I. That becomes 2 times 3, which is 6, and then 2 times negative I is minus 2i. And now the bottom of the fraction, we do FOIL for this one. 1 times 1, that's 1. 1 times negative I is minus I. I times 1 is plus I. And I times negative I is negative I squared. So right now, to simplify, these guys are going to cancel out. So I have 1 minus I squared. But I squared is negative 1, so that's 1 minus negative 1. Minus a negative is plus a positive. So that becomes 1 plus positive 1, which is 2. So the bottom of this fraction now is 2. Now I see that I don't see that number up there because it's not reduced. Technically, what we mathematically should do is write this as 6 over 2 minus 2I over 2, which is 3 minus I. So that would be my answer for that one. And that's right here. Okay. For this one, again, it's confusing because we have i's and we have square roots of negatives. So I'm going to simplify a few things. First of all, square root of negative 3 is I times the square root of 3. And the square root of negative 12 is going to be I times the square root of 12. And for now, I'm just going to leave it as square root of 12. Eventually, I'll have to take things out, but right now I'll do that. So now I have I to the third. That's right here. Square root of negative 3 is times I times the square root of 3. And then I have times I to the 6th. And then times I times the square root of 12. And when I do this, I have I to the third times I. This is I to the first, if you think about it, I to the first. So that's going to be 3 plus 1 is 4. 4 plus 6 is 10. 10 plus 1 is 11. So I'm going to write this as I to the 11th times the square root of 36. So 3 times 12 is 36. So that's going to be 6. So it's 6. Now I've got to figure what I to the 11th is. That's going to be I to the 4th, I to the 8th times I to the 3rd. This goes to 1, so I to the 3rd is negative I. So 6 times negative I, or negative 6I. So that's what we get for this answer right here. Okay, as we move on a little bit, we're going to look at this. The product means multiply, so I'm going to multiply 2I goes to 5, and then it goes to 3I. So 2I times 5 is 10I, and 2I times 3I is 6I squared. But remember, I squared is just negative 1. So that's 6 times negative 1, or negative 6. So the answer is 10I minus 6, or we don't write it in that form. We put the real part first, so that's negative 6 plus 10I would be the answer to that one. So C is the answer to number 11. Okay, and now we're going to move on to number 12. Product means multiply. 4 plus 5I and 3 plus I. So to do this, we're going to do FOIL, just like we always did. 4 times 3, that's 12. 4 times I plus 4I. 5I times 3 plus 15I. 5I times I plus 5I squared. So basically, I'm going to simplify this. 12, these two combine together to be plus 19I. And now I squared is negative 1. So this is 5 times negative 1, which is minus 5. And now I simplify by combining like terms. The 5 and the 12 do not have any i's with them. I combine them together. 12 minus 5 is 7. Plus, and then the plus the 19i. So that's the answer to that one right there. And as I move on, now this one's a little tricky because we have an I in the denominator. So I have 5 over 1 minus 2I. For this problem, to get rid of the denominator, at least the I in the denominator, we're going to multiply the top and the bottom by the conjugate of the denominator, which is basically the same thing, but change the middle sign. In this case, it's minus. We change that to plus. So 1 plus 2I for both of them. Now, the top of the fraction becomes, again, remember, this whole is in parentheses, or the idea is parentheses. 5 times 1 is 5. 5 times 2I, so that's going to be plus 10I. And that's the top of my fraction. The bottom of my fraction is going to be 1 times 1 is 1. Then it's going to be plus 2I. And this one's going to be minus 2I. And then these guys are going to be minus 4I squared. So now these two combine together to cancel out. And that's always going to happen if we have conjugates. The middle term will always cancel out. That's why we chose this number, so it can cancel out. So I have 1. Remember, this equals 1 minus 4I squared, but I squared is negative 1. So 1 minus 4 times negative 1, which is 1 plus 4, which equals 5. Because negative times a negative is positive, so that'd be good again. So the bottom of my fraction becomes 5. And again, that doesn't work. Technically, what we're supposed to do is separate this into two fractions, 5 over 5 plus 10 over 5I. 5 over 5 is 1. 10 over 5 is 2. 1 plus 2I would be the solution to that one. And we're going to move on. Okay, we're going to have to express the square root of negative 12 as an imaginary number with I. Well, first of all, the negative in the square root just comes out. So I times the square root of 12. So the square root of 12, I'm going to remember 12 breaks down to be 2 times 6, which is 2 times 3. So 2 times 2 times 3 is 12. So it's I times the square root of 2 times 2 times 3. Remember, in the side of the square root, we have pairs that can be circles. So these guys, one of them crosses out and one of them comes out front. So I have 2I square root of 3, and that's the final answer right there, B. Next problem, the conjugate. Now the conjugate, don't get confused with the opposite. Conjugate, the first part of the conjugate stays the same. The second part, we change the sign to be, if it was minus, we change it to plus. If it were plus, we change it to minus. So 2I squared of 3, and that's the answer. Negative 6 plus 2I squared of 3. So that's the answer to number 15. Now we're going to move on to number 16. Express as equivalent fraction with a real denominator. We're going to do similar to what we did a few minutes ago. 1 plus I. We have to get rid of this I on the denominator, so we multiply by the conjugate of 1 plus I, which is 1 minus I on top and bottom. So the top of the fraction, we just multiply 1 times 1 minus I is 1 minus I. And the bottom of the fraction is multiplying these two together. 1 times 1 is 1, and this is going to be minus I, and this is going to be plus I, and this is going to be minus I squared. I think we did this exact thing on the bottom earlier. These cancel, so 1 minus I squared is 1 minus negative 1, which is 1 plus 1, which is 2. Bottom of this is 2. Now, the answer that I see is right here. Technically, that's not the way we would write a complex number. Generally, a complex number would be 1 over 2 minus 1 over 2I. But since this is the answer they gave us, so that's the best we can have for number 16. Now let's move on to 17. We're finishing up soon. Same idea here. I have 5 over 3 plus I, so the conjugate would be 3 minus I for top and bottom. So remember, this becomes, we have to distribute this way. So 5 times 3, that's 15. 5 times negative I is minus 5I. And now the bottom is going to be 3 times 3, that's 9, minus 3I, plus 3I, minus I squared. So again, as always happens with conjugates, these are going to cancel out. I have 9 minus I squared, which is 9 plus 1. Minus the negative 1 is 9 plus 1. So the bottom of this fraction is 10, and I don't see that there. Mathematically, we should split it up, but they didn't up here. So when we reduce this, we notice that all three of these numbers are divisible by 5. So that's what I'm going to do. I'm going to divide each one by 5. This divided by 5 becomes 3. 5 divided by 5 becomes 1, and 10 divided by 5 becomes 2. So the answer would be 3 minus I over 2, which is A. Seems like we have a lot of A's on this quiz. Okay, this problem here, it's the same principle. 6 over 2 plus I. I multiply the top and bottom by the conjugate, which is 2 minus I over 2 minus I. So at this point, I'm going to distribute the top. That's going to be, eventually I'll do the bottom too. Distribute the top. 6 times 2, that's 12. 6 times I, so it's going to be minus 6I. And now the bottom is going to be 2 times 2, that's 4. And that's going to be minus 2I. And this is I times 2 is plus 2I. They're going to cancel out. I can see that. And it's going to be minus I squared. So now I look at this and say negative, those two will cancel. So 4 minus I squared, which is 4 minus negative 1, which is 4 plus 1, or 5. So that will be my answer. There's no simplifying of that. 12 minus 6I over 5 is D. So that will be the answer to this problem here. All right, the next problem we had a lot of difficulty with for obvious reasons that we'll see at the end. We have 2 minus 3I, and now the bottom is 4 plus 2I. So what I need to do is to get rid of this I in the bottom, I need to multiply by the conjugate. The conjugate of this is going to be 4 minus 2I. And we do the same on the top. So this now, when I do the FOIL, 4 times, what I like to do when I have a lot of problems like this with a lot of applications to do, or a lot of problems to do. I do 2 times, on the numerator up here, that's going to be 8. And then I have 2 times negative 2I is minus 4I. And then the bottom is going to be negative 3I times 4, which is minus 12I. And then negative 3I times negative 2I is positive 6I squared, which can be simplified to 8. These two guys, let's do a different color here. I'm going to erase this. Hold on a second. 8. These two will combine to be minus 16I. And this is going to be 6 times negative 1, which is minus 6. So that's going to be 2 minus 16I. That's the numerator for this answer. The denominator will be 4 times 4, that's 16, minus 8I, and then this is going to be plus 8I, and then it's going to be minus 4I squared. So these are going to cancel, and I'm going to have 16. Remember, minus, this is my negative 4 times negative 1, so it's plus 4, which is 20. So 2 minus 16I over 20 would be my answer. To reduce this, I'm going to reduce each of these by 2. And what happens is this can be a 1, this will be an 8, and this will be a 10. So I have 1 minus 8I over 10, and I look for that, and I don't see that here because it's not there. There's no answer for this. This is the correct answer, which I apologize for that. Everybody got extra credit for that anyway. So there is no answer for that up there. The last problem was quite difficult. Some of the answers were hard to see on the answers thing. There were some complaints about that. Also, it's quite a confusing problem. 3 minus I squared of 2 over 2 plus I squared of 2. So I multiply top and bottom by the conjugate of the denominator. So 2 minus I squared of 2. 2 minus I squared of 2. And you have to be really careful when we're doing these multiplications, because these i's and square roots can be quite confusing. So first I'm going to just take care of the numerator. So the numerator is 3 times 2. Let's get a different color for that. 3 times 2, that's 6. 3 times I right negative, so negative 3I square root of 2. In the middle, these two is going to be minus 2I square root of 2. And then the last terms here is going to be plus 2I squared, because square root of 2 times square root of 2 is 2, and I times I is I squared. So that's going to simplify to be 6 minus 5I squared root of 2. Remember, plus 2 times negative 1 is minus 2, so that's going to be 4 minus 5I square root of 2. That's the numerator. Now the denominator, we'll be multiplying these together. 2 times 2 is 4. Now these are end up going to cancel, minus 2I square root of 2. And this is going to be plus 2I square root of 2. And then the last one is going to be I squared. Square root of 2 times square root of 2 is 2. So it's going to be minus 2I squared, which these will cancel. So it's going to be 4. Remember, I squared is negative 1, so negative times a negative is plus 2, so the bottom of this is 6. So now I simplify that by writing it as 2 fractions to make a complex number. So that's going to be 4 over 6 minus 5I square root of 2 over 6. The correct way to write this is to put the I at the end. So that's kind of what we're going to do here. We're going to say 4 over 6 reduces to 2 over 3. And that's going to be 5 square root of 2 over 6 times I. And A would be the correct answer for that one. Now, I know there were some people complaining they couldn't see the A on the paper. It wasn't copied correctly. I'll adjust for that. I hope this helps a little bit. I know these last problems are a little complicated, but it takes practice, and we'll get to where we need to be with that. Okay, have a good night.